So calculator 101, I know we've used the calculator here and there a little bit, but the calculator is a tool, and it is a tool, not a crutch. Some people use it as a crutch when they're adding numbers like 5 plus 7. They doubt themselves and they pull out the calculator to get 12. Some people use it as a stretcher, which is even more worse than a crutch, right? But we're going to use it as a tool, right? And the tool is it can do complex calculations, and it works really, really well with decimal answers, like irrational answers or decimal answers that are repeating. Okay, they don't find exact answers when it's an irrational number, but they find answers that are correct to many, 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 many decimal places. So what we're going to do today is learn how to find values, learn how to store values, and learn how to do stuff from the home screen so that we don't have any rounding errors. Sound bueno? Bueno. Kinder bueno. Y'all are the Kinder, and this is the bueno. Hazelnut. All right, there's only one example, and then you'll have 3 of them for your homework. So we'll be able to finish in time for you to start your homework in class. All right, given f of x is, bless you, 2x cubed minus 3x squared minus 3x plus 2. What do we know about this function before we even start? Tell me something about it.
It's odd degree.
Yeah, what family does it belong to, first of all?
It's called cubic.
It's a cubic what? Polynomial. It's a cubic polynomial, and it has, what's the maximum number of x-intercepts or roots? 3. Good. How many? What's the maximum number of relative or local extrema? 2. It can have 2 turning points or 0, right? You can't have 1. What is the right end behavior? Positive or negative infinity?
Positive.
Positive infinity, because the 2 is positive. What's the left end behavior?
Negative.
Negative infinity. Good. We got all that. Okay. So the first thing that we're going to do then is we're going to put it into y1. So go to y equals. No, I'm frozen already. Hang on. This thing freezes up every once in a while. Go to y equals and carefully type it in. 2x caret 3, click to the right, minus 3x, you got a squared button there, so you don't need to go caret 2, minus 3x plus 2. Make sure that you click to the right after you do the cubic exponent. Otherwise, everything that you're writing after that will be in the exponent, and you don't notice it, and you look up and you're like, I'm stupid, right? Double check, though, triple check. How does it look? Does it look good? Okay, so if you just hit zoom 6, you'll get an idea of what the graph looks like. It has a local max, then a local min, and it has 3 x-intercepts. We want to find f of 2.5 and determine if it's increasing or decreasing. Okay, let's focus on f of 2.5 first. There are 2 ways to do it. The first way is from the graphing screen. Now, if you're going to do f of 2.5, that means that 2.5 has to be in your x window. If you do zoom 6, you can find any y value from x equals negative 10 to 10, because that's what the graphing screen is. So how do you do it from the graphing screen? You hit the trace button, which will give you an ordered pair at the bottom, and then you just type in a 2.5. And you hit enter, and you get 7. Okay, now, what's nice about doing it from the graphing window is you can get the little cursor blinking right there. At this point, is the function increasing or decreasing? Increasing. So we're going to say f is increasing. We'll abbreviate it INC at x equals 2.5. Okay, so we would list it as an x value. Now, how would we do that same thing from the home screen? Go to the home screen, hit second mode. You can recall the function by hitting alpha trace number 1. Alpha trace activates the F4 menu, which is where all your y's are located. And then you open parentheses, put in a 2.5, and close parentheses and hit enter. And that gives you a way to calculate the y value for an x value as well. You don't see the graph, so if you wanted to know if this is increasing or decreasing at this moment, it's not as easy to determine that. How could I do something on the home screen, though, to see if this is increasing or decreasing? Find the y value where? The graph was easy. It was blinking at a place where the graph was going up. How could I use something about the function in the future to help me understand if it's increasing? Do what?
Can you just plug in 2.5 for all the x values?
Well, I plugged in 2.5 and I got a 7. Oh. I want to know if the graph is going uphill or downhill at that moment.
Oh.
What if I did what if I calculated another y value? What would be another good y value to calculate? At x equals what? 3 is in the future, isn't it? But 3 is still a half unit away.
2.51.
2.51. That is a great, great thing to say. 2.6 might work, but 2.51 is even better. It's 1/100th of a value away. If I hit enter, I can compare the two, right? What happened to my y value when I went from left to right? Did it go up or down? It went up, so we can tell that it's increasing. So this is how we can use data to help us understand what's happening with the function. Okay? All right, now I'm going to add one. Well, let's do part B. F of 0.5. Let's get used to doing it from the home screen. Let's hit alpha trace number 1, and let's put in a 0.5, and we get 0. So f of 0.5 is 0. We just stumble upon a what? An x-intercept, right? An x-intercept. Okay. So is it increasing or decreasing there? Well, alpha trace number 1. Let's evaluate it where? At 0.5 what? 0.51. And you get a negative value now. So f is whating? Yeah, so in a complete sentence underneath there, we'll say f is decreasing, DEC is fine, at x equals 0.5. All right, part C, find f of negative 1.5. Okay, so we'll do the same thing. Alpha trace number 1, open parentheses, negative 1.5, close parentheses, and look at there, we get negative 7 now. To determine if it's increasing or decreasing without the graph, because we don't want to rely on the graph, we'll go negative 1 point what? 4.9. There you go. 4.9. That would be the value that's 1/100th of a unit to the right of 0.5. So in negative land, you got to be careful. We're making it a tenth smaller. And what happened to the values? If they get bigger or smaller? 0.6 is actually bigger than 0.7, right? Or negative 7, sorry. Negative 6 is actually bigger than negative 7. So f is whating? Increasing at x equals negative 1.5. All right, do one more. Let's call this C2. I want you to find f of negative 13.8. Find f of negative 13.8. And then determine if f is whating there? Increasing or decreasing? Yeah. Second mode. Quit. To get to the home screen, you just quit. Quit is second mode. Second, and then the button right next to it is mode. That quits and gets you back to the home screen. All right, now look, if you try to do this one from the graphing screen, because I know you might be like, why don't we just do it all from the graphing screen? That way we don't have to plug in that second number and compare. We can just see where it's blinking. If I just hit trace here and type in negative 13.8, what's going to happen? I'm going to go off the screen and it says invalid. So what are you going to do? Well, you have two options. You can either go back and change your window, go to window and change your X-min to like negative 15 and then wait for it to graph and do it again. Or you say, I don't even need the freaking graph. I'll just go to the home screen, alpha trace, enter, and then I'll type in negative 13.8, close it up, and I get equals negative 5784. Now, how many decimals should we report?
3.
3, yeah. This one actually only shows 3, but if it goes past 3, we always report 3 decimals. We always report 3 decimals. So 3 decimal accuracy. No, you just chop it off. You can round or truncate. Round or truncate. I'll write that. Report 3 decimals. Round. Truncate means to just not round. It means literally to chop off. Chop off. Round or truncate. Okay. Now, to see if it's increasing or decreasing, we'll alpha trace, enter. What's the value that is just to the right of there?
Negative 13.79.
Negative 13.79. And you compare it, and the value is what? It's bigger, right? It's bigger. It's less negative. So it's bigger. So F is increasing at x equals negative 13.8. I want you to write out that complete sentence. Don't just put increasing. I want you to put F is increasing at x equals negative 13.8. Okay. Find the y-intercept and determine if it's increasing or decreasing. All right, how do I find the y-intercept? F of 0. So I show that. I put F of 0, and again, I'll go alpha trace, enter, parentheses, 0, and we get 2. Now to see if it's increasing or decreasing, we'll do alpha trace number 1, and then we'll plug in a value that's just to the right of 0, like 0.1. Yeah. Oops, I got to get out of there. 0.1. And it's going down. So we'll say F is decreasing, DEC, at x equals 0. All right, y'all got it? All right. Now it's going to find the local max, the local min. That's the local extrema. I think we've already done this before, but let's do it again. We can't find the local max or mins unless we know calculus or we have a calculator. Today we have a calculator, don't we? So from the graphing screen now, we do this from the graphing screen. We go second trace, that's your calculate menu, second trace, and let's find the maximum first. We'll go from left to right. So we'll choose number 4. It asks us for the left bound, so we'll scroll to the left until we know we're to the left of the high point. Right there, we'll hit enter. And then for the right bound, we'll scroll to the right until we know we're to the right of the high point, somewhere in there. We'll hit enter. And it blocks off that little interval. And for your guess, you could just hit enter, and we get it right there. So now we'll say F has a local max, and we say of, and we write the y value, y equals 2.598, at x equals negative 0.366. So far, so good. 3 decimals. I'm a big truncator, so you'll notice that if I'll never round, but in this case, these are the same if you round or not round. All right, then we do the same thing for the min. Second trace number what this time though? Min. That's number 3. So we'll come down here to the left of the low point. We'll hit enter. Click to the right until you turn the corner and you see that you're coming back up. Hit enter. And for the guess, you can hit enter. And now we say F has a local min of, let's do the of first, because I want you to remember that the minimum value itself is the y value. It's not the ordered pair. It's the y value. So it's negative 2.598. And then we'll say at the location is x equals 1.366.
So for the y, we also put negative 2.60.
If you, well, no, if you're doing 3 decimals and you're rounding, yeah, it would still be 0.598. It would be 0.60 if you rounded to the nearest 10th or 100th. Sorry, we're doing to the nearest 1,000. Okay, now let me rephrase this question. It says find f of 3.5 minus find f of negative 2.5. Let's scratch out that find. That's an errant word. It's not supposed to be in there. Find f of 3.5 minus f of negative 2.5. Okay, so here's what we could do. We can A, go to the home screen, and we can calculate them individually. Alpha trace number 1 of 3.5, and we can write it down underneath there, 40.5, minus, and then we can do it again, alpha trace number 1 of negative 2.5, and then we get negative 40.5. And then we can come back to our home screen, and we know that that's the same as 40.5 plus 40.5. And I think we can add those in our head, but let's say that they were ugly numbers. Then we have to type them back in. 40.5 plus 40.5, and we get 81. I do not want you to do it like that. That's too much writing, And in the event that those values were like decimals that you rounded or truncated, you're not going to get the right answer at the end. It could be off. You could get rounding error. So here's how I want you to do it. F of 3.5 minus f of negative 2.5. I want you to add it like that directly on the home screen. So we'll go alpha trace number 1 of 3.5, close parentheses. And here's why we do it from the home screen and not from the graphing screen. I can now do algebra. I can say minus, and I can just do the next one, alpha trace of negative 2.5. I don't have to worry about writing down intermediate answers. I don't have to worry about storing those values if they don't go to 3 decimals. I'm just letting the calculator compute everything, and it's giving me one answer at the end, 81. See how that works? That's why we like to do it from the home screen. We can actually perform algebra. Now, here's taking it to the next level. Let's find f of pi. F of pi, that's alpha trace 1 of, and then where's the pi button?
The caret.
It's on the caret symbol. So whenever we use pi, we won't type in 3.14. We'll actually use the caret symbol, which is the second function for pi. Okay, you hit that, and then we get a. It says to call it a, so we're going to get a equals 24.978. Now, how do I store that as a? If you just hit stow, which is on the left-hand side right above the on button, it'll take the answer from the previous line, and it'll put an arrow. And now to store it, you do alpha A. You activate the alpha key, and right below it is the A button, and you hit enter, and now it's locked in there as A. If you call it A on your calculator, you're going to call it A on your paper, and vice versa. So now anytime I hit alpha A, enter, I'm going to get that number. Alpha A, enter, I'm going to get that number. Let me show you another thing that's important with the calculator. Let's say that I found that value, 24.976, from the calculator. If I go to my graphing screen and hit trace, I can hit second pi. It'll evaluate it right there. Okay, and notice it says the y value is what? 24.978. Is that what it is? Yeah, now notice it's not blinking on the screen because guess what? It's off the screen. Your x values have to be on the screen, but your y values can be off the screen. What if I wanted to store that y value as a? Watch this. If you go to your home screen, second mode, if you quit, look what happens if you hit X, enter. It temporarily stores whatever on the graphing screen is as X, it temporarily stores it as X. Hit alpha 1, enter. Alpha 1 is where the Y letter is located. Hit enter. Look what's there. It's the Y value from the graphing screen. It'll store those things in X and Y temporarily. If I were to go to the graphing screen and find something else, like watch this. If I went to the graphing screen and evaluated trace at 3.5, now I get these values. Look what happens now if I hit X enter. I get 3.5. Look what happens if I hit alpha 1 enter. I get 40.5. So it always overwrites the X and Y every time you go to the calculator. So back to where we were. If I did it from the graphing screen and I wanted to evaluate it at pi, like that, it now has that stored as X and it now has that stored as Y. I can now store that value as A still. Here's how I do it. I just hit alpha 1, which is my Y value, and then I hit store as alpha A. I take the Y value that it temporarily stored it in, and I'm storing that now, arrow, as alpha A. And now it's in alpha A. Okay? If I wanted to store the X value, let's store pi as B. I can hit X, and I can store that as alpha B. Okay? Now every time I hit alpha B, it's going to be pi. Alpha B is going to be pi. This is what we do if we use the graphing screen to find x-intercepts or local max or mins. If I need to find multiple of them, but I need to come back and get the exact value of those answers, I can store them before I find the next set as A or B or C or D. We got the whole alphabet. But the X and the Y, this is important to know, the X and the Y are temporarily stored as X and Y. And the next time you find something on the graphing calculator on the graphing screen, it'll overwrite them. Okay, so anyway, back to where we were. Let's review what we did. I found f of pi So I did it the right way, alpha trace of pi, right? And then I stored that as alpha A, boom. Now, what is 3a minus 5a? Well, this is why we wanted to store the value. I don't want to use 24.978 because that's a rounded number or a truncated number. And if I use that for a subsequent calculation, I'm going to get what's called rounding error. So here's my question to you. You can write this down. When do we use a rounded answer for a subsequent? You know what subsequent means, right? Subsequent means follows. When do we use a rounded answer for a subsequent calculation? What do you think the answer to that is?
Never.
Never. If we can help it. Never. Never if we can help it. So if you know you want to figure out what f of pi is, and it's 24.978, you better store 24.978 so that you're using the calculator's full stored decimal version, the live answer, and not your rounded number, okay? That's a very important thing. All right, so now, if I wanted to find 3a minus 5a, I could just type it into my calculator like that. 3 alpha a minus 5 alpha a, and the calculator is going to use the stored value with all the decimals. And now I get negative 49.957. There's your answer. Now, just for kicks and grins, let's see if we would get the same answer. If I have 24.978, which is my rounded answer, let's store that as alpha b. So we're storing the rounded answer in b and the live answer with all the decimals in a. If I do then 3 alpha b minus 5 alpha b, do I get the same answer that I got when I used the live version? I don't, do I? I got negative 49.957 when I used the actual stored values. But when I used my approximated answer, I got negative 49.956. That's what we call what? Rounding error. Do you want to drive on a bridge or go in a tunnel where someone's been using rounded numbers for all of their calculations? Heck no. I'm not driving on any bridge where the engineers were using rounded numbers for subsequent calculations, because that thing is not going to be safe. It's not going to meet the tolerances. You're going to have rounding error all the way across the bridge. It compounds. Rounding error compounds. The more times you use a rounded number for a subsequent calculation, the more it compounds and the less you're going to be hitting your mark. Okay, the other thing that we like to do is find the roots. Now here's how I have you find the roots. I have you graph the function y1, and then I have you graph 0 and y2. So let's go ahead and do that. We'll go to y2, and we'll graph 0. And you should see the red line up here. Now the reason I have you graph 0 is even though your calculator can find roots without graphing 0, with 0 graphed as a separate equation, you can actually find their points of intersection, which is really what we want, isn't it? We want to know where those two graphs intersect. Your calculator can find points of intersection faster than it can find roots. Watch this. Second trace, and instead of using the 0 command, which requires you to go left bound, right bound, kind of like we do local max or mins, we're just going to use the number 5 intersect command. Now, the intersect command will not work if you don't graph 0 and y2, but we always will. So it's going to say, hey, is this your first curve? And it puts you on the polynomial. I'm going to hit enter, yes. It's going to say, hey, is this your second curve? And it puts you on the line y equals 0, and you're like, yes. And now all you got to do for your guess is to scroll close to the one you want. Let's go ahead and scroll close to this one over here. All right, I'm going to hit enter, and it gives me -1. So here's what I'm going to do. I'm going to say x equals -1, and I'm going to store that as alpha a. I'm done with using my a for the previous problem. So how am I going to store that as alpha a? Let's go to the home screen, hit x stow alpha a, and it'll store it as -1. X, it stored it temporarily, x stow alpha a. All right, so we got the first x-intercept stored as a. All right, let's go ahead and find the next one. Go back to your graph, second trace number 5, enter, enter, and this time you scroll close to the second one. And we get 0.5. We already knew about that one. We found it again. Let's store that one as B. Let's store that one as B. So go to your home screen, second mode, quit, and hit X. I'm sorry. Yeah, X. It stored it as X. We're going to hit store. This time we're going to hit alpha B. It overrode the -1 from the previous calculation and put a 0.5 in there, but we stored it as A, and now we can store this one as B. These are exact values, so you can type them in if you want. But in the event that these x-intercepts were ugly decimals, which when we move forward, these are going to be ugly numbers, we're storing these ugly numbers in their full decimal glory, okay? Let's go to the graph one more time. Second trace, number 5. Enter, enter. And then we just scroll a little bit closer to the third and final x-intercept. And we get 2. And let's store that as what? What's the next letter in the alphabet? C. So I'm going to go to the home screen, second mode. And now I'm going to hit X, stow, alpha C. Hit enter. And there they are. Got it? We're storing the X values as we find them. As A, B, C, whatever letter we want. Okay, so now look at part I. It says, I wrote this in there. It's my handwriting. Find the product of the roots. Okay, so now I can just say the product is equal to A, B, C. Here's what's nice about storing them as A, B, C. I can write them down on my paper as A, B, and C as well. That reminds me where I'm storing the values. And to get credit for your process, remember, I always want to see your process, how you arrive at your answer. You can use A, B, and C as an intermediate calculation. That tells me you're multiplying your A times your B times your C, and I look up above and I see what they are. But you don't ever have to write down -1 and -0.5 and 2 again. You remember your first question on the test yesterday? Find RSTV. It's the same thing. We're finding them A, B, C this time. Now on your calculator, just go alpha A times alpha B times alpha C. And what are we going to get? We get -1. There's the product of the roots. Okay. Any questions on that? Storing values as A, B, and C, especially when they're ugly values that you can't reproduce, right? In this case, if I didn't store it as A, B, and C, I could have just written down -1 times -1/2 times 2 and figured it out like you did on the test yesterday. But this is so much quicker, even when they're nice roots, but it's even more advantageous to do it this way when they're ugly decimals like f of pi. Okay, I want you to do one more thing for me. I want you to do this. Let's add the x values of the local extrema. This is your closing task. Okay? Add the x values of your local extrema together. We'll call this part J. This is your closing task. Your exit ticket, if you will. We already found the x values of the local max and mins, don't we? But are you allowed to just come back up here and just add these together right here? No, because those are what types of numbers now? Are those exact? No, those are rounded numbers, so you can't just come back up there and add those together. You have to find them again. Actually, instead of adding them, I think you're going to get 0. Let's do this. Let's multiply. They are going to have symmetry. Let's just multiply the x values of the local extrema. I'll give you a minute. Are you going to have to store these as A and B or something like that? Yeah, you're going to have to refine them, which is good for you. And then you're going to have to store one of them as A, store the other one as B, and then you're going to write the product as A times B. I'm giving you abs today. A, B, A, B.
So the worksheets due tomorrow?
Yeah, the worksheet's due tomorrow.
Is it open?
It is. It should be open in Canvas.
Oh, it's in separate here.
Yeah. All right, I'm going to do it with you in case you're lost. Here we go. I go back to the graph, and to find the local max, I hit second trace number what? Number 4. It's on the blue curve, so I go to the left of where it is, I hit enter. I go to the right of where it is, I hit enter. And for the guess, I hit enter. There it is. Okay, I'm going to write it down again. X equals negative 0.366. And now I'm going to call that A. So now I go to my home screen, and if you hit X stow as alpha A, because we're done with the other A, there it is. See how ugly that number is? See all those decimals that appeared? The calculator found those. Those are real live numbers in the answer. I'm going to store that as A. I already did. All right, now I do the next one. Second trace, I go to the graph, and then second trace number min, that's number 3. To the left of it, hit enter. To the right of it, hit enter. And I get X equals 1.366. I'm going to call that B. So now I go to the home screen, and I hit X stow alpha B. Boom, and there it is. And now all I have to do is say the product is going to be AB. And now from the home screen, I just hit alpha A. I don't even have to put times. If you just put alpha A, alpha B, your calculator knows when two variables are side by side to multiply them. And look at there, you just gave yourself abs. Now, what would the answer be? It would be negative 0.499 if you truncate. Or what would it be if you round? Negative 0.500. Would you need those two trailing zeros? You absolutely would, because it's not a terminating decimal. If you notice back at the end, you get 89172. So,
gave me negative 0.2.
oh, yeah, depending, okay. Really? Did anyone give them negative 0.500? Yours did also?
Mine did. But mine gave me a little bit different of a number. I have 703.
Huh. Okay. I find that interesting. That means that the calculator is using a different method to find the max and mins depending on what window you're in, or whatever, how close you blocked it off. That's the first time I've encountered that. That's interesting. Let's do it again. You did second trace number 4 for the max, and you blocked it off somewhere to the left, and you blocked it off somewhere to the right, and you got negative 0.366026. If we go to the home screen, we hit X enter, that should be the X coordinate. If we're all in the same window, and this is something that
See,
I haven't encountered.
I have a different number.
Oh, you got 9.4 at the end instead of 9.6.
I have 308 at the end.
Okay, so I guess depending on where you do your left bound border and your right bound border, I guess you get a slightly different number as it scans that interval. But it's way down the decimal line. So usually the answers are correct to 3 decimals, regardless of what numbers you get. But here's the first time where they're not correct to 3 decimals, because if you just got 0.500, you wouldn't get 499. But I would accept either one of those answers. So it should be correct. I'll tell you that. The answer should be correct to 3 decimals whenever you round or truncate. If there's slight variations, it's going to be way down the decimal line.
This time I got net 0.9.
See? Yeah, I don't understand. Yeah, because you chose the different left bound, right bound. I guess if you can choose a left bound and a right bound that are closer to the max, it gives you a better estimate. If you choose a left bound, right bound that are farther away from the local max, you get a slightly different number. I didn't realize that. And I don't know if it's a difference between the calculator emulator and the handheld, but y'all are getting different numbers on the handheld as well. So I guess as to say a method of good practice, let's do it again. Second trace number 4, max. We should really choose the left bound that is as close to the high point as possible, and we should choose the right endpoint that is as close to the high point as possible. If you can make that interval that it has to scan smaller, I'm guessing then that the result is going to give you See, I even got a different number right there. I just did it twice in a row and I got a slightly different number. All right. I'm learning something new today about the calculators. I didn't think it mattered, but I guess it does. So, as a general practice, when you're trying to block off an interval, try to make it, it's correct to 1, 2, 3, 4, 5. It's correct to 5 decimal places, but after that, they vary depending on how close your guess is. So, block it off as close to the max as you can. Block it off as close to the min as you can. The whole point of storing these values is we're trying to avoid rounding error, right? We're trying to be as accurate and authentic as possible. So keep that in mind. All right, cool. I'm glad that came up. We should still be correct to 3 decimals, rounding or truncating. All right, that's it. That's all I have. Any questions or comments? Cool.